Hey friends, welcome back to our Python tutorial series. This is tutorial 5, and today we are diving into one of the most powerful concepts in programming, control flow. In this video, you will learn how to make decisions in your programs using if, elif, and else statements to handle different situations, multiple if statements for independent checks, and nested if else for complex logic. Then we will practice with real-life examples. Are you ready? Let's go. What is control flow? Control flow in Python refers to the order in which statements are executed in a program. By default, Python executes code sequentially from top to bottom. However, control flow statements alter this execution order through conditional statements, if, elif, else, iterative statements, for, while, loop control statements, break, continue, pass. This allows for complex logic and nonlinear execution. Control flow statements. In Python, we use different types of statements to control the flow of a program. We start with the conditional statements like if, elif, and else, which help the program make decisions based on specific conditions. Next, we have iterative statements, such as for loops and while loops, which allow us to repeat actions multiple times, either for a set number or until a condition is met. Then, there are loop control statements, break, continue, and pass. These give us final control inside loops. Break stops the loop entirely, continue skips to the next iteration, pass acts as a placeholder when no action is needed. In this tutorial, we will focus on conditional statements. In upcoming lessons, we will explore iterative and loop control statements in more detail. Conditional statements. In Python, conditional statements allow us to make decisions in our programs. The simplest form is the if statement. It runs a block of code only if a condition is true. We can extend this with if, else, which runs one block of code if the condition is true, and another block if it's false. Now let's say we have multiple conditions. For that, we use elif, which stands for else if. Python evaluates conditions in order and runs the first one that's true. And finally, we can place one if-else statement inside another, creating what's called a nested if-else. These structures give our code flexibility, letting it responding differently depending on the situation. Now that we know what each type of conditional statement is, let's look at how they are written in Python. Here is the basic if. We write if followed by the condition, and then the indented block of code to run if it's true. Let's break down the if-else logic to understand how conditional statements work. Start with if followed by a condition to test. If the condition is true, Python executes block A, which is the indented code under if. If false, it jumps to else and run block B instead. Notice that the else should be at the same indentation level as the if. And remember, a block of code is a group of indented instructions inside these statements. Indentation is just the spaces at the start of a line, and it's essential for Python to understand your code structure. With if, elif, else, we begin with if, then add one or more elif blocks for additional conditions, and an optional else block. Finally, we have nested if-else statements. This means placing one if-else inside another, allowing for more detailed decision-making. Now let's open PyCharm and see these conditional statements in action. First, the simple if statement. We start by defining the variable age set to 18. If age is greater or equals 18, print you can vote. Here we check if a person's age is 18 or older. If true, it prints you can vote. Click Run. As expected, the message is displayed since age is 18. Next, the if-else statements. This adds a fallback. Age equals 16. Tap to complete. I'll press on the tab key. So if age is greater or equals 18, print you can vote, else print you can't vote. If the condition fails, like when age is 16, it prints you can't vote. I'll comment out these lines of code to test the new ones. Click Run. As expected, the message is printed, you can't vote, since age is less than 18. But what if we have more than 2 possibilities? That's where elif statements comes in. So let's comment out these lines of code and let's create a grading system using if, elif, and else structure. Score equals 85. If score is greater or equals 90, print grade A. elif, which stands for else if. I'll press on the tab key to autocomplete. So elif score greater or equals 80, print grade B. elif score is greater or equals 70, print grade C, else print grade D. Click on the Run button. Since the score is 85, which falls between 80 and 89, the grade is B. Multiple if versus elif. What if you want to check multiple independent conditions? In that case, you can use multiple if statements. But what's the difference between multiple if statements and an if, elif, else structure? With if, elif, else, only one condition can be true. So only A, B, or C will run. Once a true condition is found, the rest are skipped. With multiple if statements, each condition is evaluated separately. This means A, B, and C can all run if their conditions are true. Now let's open PyCharm and try an example of multiple if statements. First, we will define 2 variables. Temperature equals 30 and humidity equals 80. Now we will use multiple if statements to evaluate these conditions. If temperature is greater than 25, print it's hot. If humidity is greater than 70, print it's humid. Click Run, and as you can see, both messages appear because both conditions are true. This shows how multiple if statements work independently, unlike elif. Nested if-else statement. A nested if statement is an if statement placed inside another if or else block, allowing you to check multiple conditions in a specific order. Here's how it works. First, Python checks condition 1. If condition 1 is true, it moves inside and checks condition 2. If condition 2 is also true, it runs the first block, block A. But if condition 2 is false, it runs the nested else block, so it does block B. Now, if condition 1 is false from the start, Python skips everything inside and runs the outer else block, block C. So remember, we use nested if-else statements to check additional conditions only when the first condition is true. Code following the flowchart logic. Before we start coding, it's very helpful to first build a clear plan, and that's where a flowchart comes in. A flowchart is a simple visual diagram that shows the logical steps for our program, making coding easier and clearer. We use diamonds for conditions and we use rectangles for actions. Now let's look at the code that follows the flowchart logic. We start by checking if the person's age is 18 or older. If yes, they are eligible to drive. Then, inside that condition, we check if the person has a license. This is where we use a nested if-else. If they do, they are allowed to drive. Otherwise, they can't drive. But if the person is under 18, the outer else runs and we print not eligible to drive. See how each flowchart step matches the code. That's how we turn logic into real programs. Let's open PyCharm and test this code in action. We will start by defining two variables, age equals 20, has license equals true. If age is greater or equals 18, print eligible to drive. So the outer if check if the age is 18 or older. If true, it prints eligible to drive, then nests a second check. If has license, I press on the tab key to autocomplete. Print you can drive. Else, see how if and else are at the same indentation level. So print you can't drive, I'll press on the tab key. If the age is under 18, it skips everything and prints not eligible to drive. So else, print not eligible to drive. Click on the run button. Since the age is 20, so he is eligible to drive and he has a license, because we have here has license equals true, so he can drive. But what if the age is less than 18? For example, 15. Click on the run button. As expected, Python skips everything inside and run the outer else block, which is print not eligible to drive. Let's put our learning into action with a project. Write a Python program that creates two variables, username and password, and assign them your chosen values. Ask the user to input a username and a password. If both match the stored values, display login successful. If the username matches but the password is wrong, display wrong password. If the username does not match, display user not found. Let's open PyCharm and build this login system together step by step. So let's comment out these lines of code. First, we will create our variables and set them with our chosen values. Username equals, for example, Peter. Password equals, let's say, 12345. Now, we will ask the user to enter their details using input function. Input user equals input, enter your username. I press on the tab key to autocomplete. Input password equals input, enter your password. Here comes the important part. We will check if the entered username matches our stored one. If it does, we will then verify the password in a nested condition. If input user double equals username, if input password double equals password. So if both match, we will print login successful. Print login successful. Otherwise, we will print wrong password. So else print wrong password. This if-else statement is a nested condition, okay? So and if the username doesn't match right from the start, Python skips the nested if-else check for the password and goes straight to the outer else block, showing user not found. So else print user not found. Let's click run to test the code. So here Peter 1 2 3 4 5. So I get login successful. What if I change the username? For example, let's say Tony, password whatever, user not found. Ready for a challenge? Your task is to write a program that asks the user to enter their weight and height, calculates the BMI using the formula weight divided by height squared. Remember, BMI is a simple health indicator based on height and weight. Here's how BMI categories are classified. A BMI below 18.5 is considered underweight. A BMI between 18.5 and 24.9 is considered normal. A BMI between 25 and 29.9 is overweight. A BMI between 30 and 34.9 is obese. And a BMI of 35 or higher is classified as extremely obese. Now let's open PyCharm to solve this challenge. We will start by asking the user for their weight and height. Notice how we use float to convert their input to numbers for calculations. Next, we calculate BMI using the formula weight divided by height squared. We wrap height to the power of 2 in parentheses for correct math order and round the result to 2 decimal places. Now, the decision-making part. We will check where the BMI falls. So, if BMI is less than 18.5, we will print your BMI is, and here is the value of the BMI of the user. You are underweight. And we use elif, which stands for else if, BMI less than 25. So here the BMI is between 18.5 and 25. So we'll print the BMI of the user and we will say that he has a normal weight. The same for the other two values. Else, you are extremely obese. If the BMI is greater than 35, so this else block will run. Now click on the run button, enter your weight, let's say it's 55, your height in meters 1.68 for example, your BMI is 19.49, you have a normal weight. For homework, write a small program that checks a person's age and prints child if age is less than 13, teenager if age is between 13 and 19, adult if age is greater or equals 20. Great job! In this tutorial, we explored the concept of control flow, how Python decides which part of your code to run based on certain conditions. We learned how to use if, elif, and else statements to make decisions in our program. We looked at the difference between using multiple if statements versus elif. Then we introduced nested if statements, which let you check conditions inside other conditions. And finally, We put it all into practice by building a simple login system and a BMI calculator. In the next video, we will explore how to use for and while loops to automate repetitive tasks. We will also understand loop control statements, and finally we will apply loops through practical examples. Thanks for watching. If you found this video helpful, don't forget to like, subscribe, and hit the notification bell so you never miss an update. See you in the next lesson.